In this video, we are going to talk about speed and velocity. Let's begin with defining speed and velocity. Speed is a scalar quantity, whereas velocity is a vector quantity. So speed refers to how fast an object is moving. And it's the rate at which an object covers distance. So we can write the definition of speed in the form of formula. For example, like that: distance over time. And this time is the time interval, the time elapsed, the time that this traveling takes place within this time. Velocity, on the other hand, is a vector quantity, so that refers to the rate at which an object changes its position. So changing position, in the previous video, we talked about changing position, displacement, and distance. So then we can write the definition of velocity in this form. Velocity is equal to displacement over time. Velocity has another difference with compared to speed, and that is direction. So velocity, since it's a vector, it has direction, whereas speed does not include any directions. For example, it would not be enough to say that an object has a velocity of 55 kilometers per hour. One must include direction information in order to fully describe the velocity of the object. So if you just simply say 55 kilometers per hour, there is no direction mentioned here. Therefore, this 55 is only perceived to be the magnitude of the velocity, or we can say it's the speed, because it doesn't have the direction. So if a car travels 250 kilometers in 3 hours, we say its average speed was 80 kilometers per hour, because average speed is defined as total distance traveled, divided by elapsed time or time interval. So we need to add a word here: total distance per time. Both of them, speed and velocity, both they have a common SI unit, and that is meter per second. So both of them have the same unit. So let's have a look at this example. A person walks 70 meters east and then 30 meters west in 70 seconds. The average speed is, so in this case, I just simply write down the formula of speed. Total distance over time. And total distance here is 70 meters plus 30 meters plus, and that's it. And we don't have any. Divided by 70 seconds, which is equal to 1.42 meter per second. So this is the speed. And about velocity, average velocity. Average velocity means displacement over time. The symbol for showing the change of the position or displacement, because displacement is defined as the change in position, change of position. We can write like x2 minus x1, which is in fact delta x. Delta x here is displacement. And delta x is a vector. Therefore, the velocity is also a vector, because displacement here is in the equation, is in the formula, and makes the quantity, which is velocity, as a vector. Let's have a look at this problem, this example. The position of a runner is plotted as moving along the x-axis of coordinate system. So this runner, firstly, he was at this position, which is x1, or initial position. Initial position is represented or denoted by x sub 1, or sometimes x sub naught, or sometimes by x sub I, which refers to initial, this I, initial position. So in this case, we are going to find out the average velocity. So I will write just average velocity. Since it's a vector, I would prefer to put an arrow above this symbol V, which shows the velocity, delta x over t. Time here is 3 seconds. So therefore, delta x, which is displacement, is equal to x2 minus x1, or x sub 2 minus x sub 1 over t, which is equal to 30 meter minus 50 meter divided by 3 seconds, which is equal to 20 divided by 3 seconds minus 20 divided by 3 seconds, which is equal to minus 6.6666 meter per second. Look at this example, which we have a let me show it we have a minus here, negative here, so the answer is negative, or minus 6.66 meter per second. And this negative here represents the direction, so this refers to the direction of the motion. That means the motion is towards left when it is along the x coordinate, x-axis of a coordinate system. When it is along x, so it must be towards left, or due west, because it is minus, as we explained in the first video, which is about frame of reference, displacement, and position. We explained in that video about frame of reference and the sign that we agree on. Let's now solve this problem. The cyclist in the figure starts cycling at point A He reaches point C in 80 seconds, returns and comes to rest at point B in 20 seconds. Calculate the cyclist's ABC. A. Average speed and average velocity in 80 seconds. Letter B. Average speed and average velocity in 100 seconds. And letter C. Average speed and average velocity if the cyclist does not stop at point B but returns again to point A from point C in a total time of 100 seconds. So let's get started with solving letter A first of all. So letter A says average speed and average velocity. So let me just write down here A. So I will write speed is equal to, and here velocity is equal to. So speed here, which we need total distance over time. Whereas velocity, I need to have delta x or displacement over time. So distance, we want to calculate at 80 seconds. So I will write just 80 seconds at the bottom of the formula. And then in 80 seconds, if we read the problem again, in 80 seconds, this cyclist comes to C. So it means that from A to C, it takes 80 seconds. So therefore, my distance is 250 meters, and my displacement also, because it's a straight line, yes, is 250 meters minus 0, which is equal to 250, of course. 80 seconds, which in both cases the answer will be equal to 3.125 meter per second. And why the velocity and speed both, they gave us the same answer? Because first of all, the direction is towards right, so both must be positive. I mean, velocity must be positive, and speed is always positive. And another reason is because in this problem, in letter A, the displacement and distance both are equal, are the same. Okay, let's move on to next part, which is part B. So I will write part B here. Average speed and average velocity in 100 seconds. So let's find out at 100 seconds where the object is. So it says that returns and comes to rest at point B in 20 seconds. So that means from C to B it takes 20 seconds to travel from C to B. So 80 seconds from A to C, and from C it takes 20 seconds to returns and comes to rest at point B. So that means during this travel from C to B, the time interval is 20 seconds. So I will just write speed again is equal to velocity is equal to. So here again I will write 100 seconds because we are going to find out 100 seconds speed and velocity. But in this time, what is distance? Distance at B. Distance at B is 250 to the right and then 50 to the left. So speed is distance is 300 meters. And how about velocity? Velocity, what is the displacement during this 100-second trip or travel? So here, when it comes to B, so let me arrange this. When the bicyclist, when the bicycle comes to, when this object comes to B, then it means the displacement is 200 meters. Because the displacement is always a vector connecting initial position to the final position. So this blue color arrow represents my displacement here, which is 200 meters. Okay. Then now I can say speed is 3 meters per second and velocity is 2 meters per second. So this is part B done, and let's move on to part C. Average speed and average velocity if the cyclist does not stop at point B but returns again to point A from point C in a total time of 100 seconds. So again, I will write part C here. I will write it like speed is equal to and velocity is equal to. So in this part, the total time traveled or time elapsed or time interval for this trip, for this round trip, because from A to C it takes 80 seconds, and then in this case part C from part letter C, from position C it takes 100 seconds to get back to A. So therefore our total time will be, the total time here will be 180 seconds. 180 seconds. And total distance here in the case letter C is 250 meters go and 250 meters come back. So therefore it will be 250 meters plus 250 meters, which is equal to 500 meters divided by 180, which will give us 2.77 meters per second. So this is the average speed. But how about velocity? Velocity, we still have not calculated displacement because we want to find out what is the displacement here. The displacement, what is delta x? What should I write on the top of this fraction as delta x? And Looking carefully at this problem, I see this object, this cyclist, goes to C and then from C comes back to A. So therefore, the initial and the final position, they are the same. So therefore, my displacement here is 0. So therefore, the average velocity here will be 0 in this case. Okay, this is the end of this session. Thanks for watching.